Hey, welcome back, physics fans. This is question number 20 from the projectile package. The muzzle velocity of a projectile fired from a gun has an upward component of 49 meters per second and a horizontal component of 60 meters per second. What's the maximum height does it reach? And how much time did it take to reach the top of the flight? So, initially, it's launched at a horizontal of 60. We want to know as it goes up to at the top. And initially is 49. And it's up. Okay, 9.8 is the acceleration. Now, what's the maximum height? Well, at the maximum height, there's something special at this location. At that location, the final velocity is equal to 0. It's not going up and it's not going down. It's 0. So if that's 0, we can solve for d and t right away. We don't even need to use the 60, we can just do this. So d is equal to, and without t, we would do it as vf squared minus vi squared all over 2a. Mr. Curl, where are you getting that from? Vf squared is equal to vi squared plus 2ad, and because that's the one without t, and just rearranging for d, we put the vi over there, and it becomes negative, and then divide by 2a, the whole thing. So that's going to be 0 minus 49 squared. If it was up or down, it don't matter, it's going to be positive, then subtract, it's going to be negative. And then it'll be 2 times 9.8. And whatever this direction is, it'll be minus, it'll be the opposite direction of acceleration. Acceleration's down, so this d is automatically going to be up. It's going to be the opposite direction. Again, it's negative up top. This is going to be, if it's down is positive, then it's negative, so that'll be the opposite. And if this is negative, that's negative, that'll become positive. It's the opposite. Okay, 49 squared divided by 19.6, or 49 squared divided by 9.8, and also divided by 2. That's 122.5 meters. And the time, well, if we want to do the time without d, we would go vf equals vi plus at, or vf minus vi all over a is equal to t. That's going to be 49 divided by 9.8, which is 5. So 5 seconds for that. Those are the answers. Now it continues on and lands at the same height. So it's one of those, and it lands at the same height. Therefore, the vertical displacement is 0. Yes, this is for the whole flight now, not for the last half. This is from launch to the landing. And so it starts off at 49 up, and it comes down at 9.8 meters per second. And you can use Mr. Curlism to find the final velocity. Well, what goes up comes down and at the same speed. That's only for level ground ones. And without friction, there we go. So the change in velocity is 98. It's 2 times that. And divide that by the acceleration, and you get the time. So the time is going to be 10 seconds. Okay, it was still launched at 60. So the distance here is d equals v times t, and that's going to be 660 times 10, 600 meters. So let's see what the questions ask for. What is the final vertical velocity? It's 49. The time for the full flight, that was 10 seconds. And how far did it go horizontally? 600 meters. So that's 600 meters. That's it. You got it. Good. Take care. Thanks. Subscribe. Like the video. See you soon. Bye-bye.